Hello, welcome to today's class. Today happen to be our first lesson in study of difference equation. My name is Sunday Oluwafemi Odobe, and I will be your instructor in this study. Alright, difference equation definition. And difference equation is a relationship between the difference of an unknown function at one or more general values of argument. What we mean is that we have an unknown function at one or more general values of argument. Example, we have y subscript n, which can equals to y subscript n plus 1 plus y subscript n plus 2 plus dot. Or we can also say that difference equation and equation involving difference operators. So that means that the first thing you need to understand is difference operators, and that will be the first thing we are going to check in this lesson 1. I know you would have heard about differential equation, which can be in the form of dy dx equals to xy plus x. And then you would have also heard about partial differential equation, where we have this sign to indicate a partial respect to x, and it can be a function of x comma y, also known as PDE. Likewise, also we have another equation which we call difference equation. But before we go deeper into it, I would love us to check the difference operators. So any equations that involve difference operators, such equation is called a difference equation. Alright, so let's check difference operator. Just relax, you'll find it very simple and very interesting. Okay, first we have two types of difference operators that we'll be checking under the study of our difference equation. The first is finite difference operators, and the other one is shifting operators. So for finite difference operator now, we have two types of finite difference operators. We have the forward difference operators. You can see the symbol as this, and we also have the backward difference operators. Let me shift my screen so that you can easily see it. Okay, you have you can see the backward difference operator, so you can see the difference. We have your forward difference operators as this, then you have your backward difference operators as this. Okay, so let's first of all check the forward difference operator. So we have your forward difference operator. Okay, so for your forward difference operator, the forward difference operator of y naught is given as y1 minus y naught. That is a step forward, then subtract your initial value of y, which is y naught, from your y1, and that is out to find your forward difference. And if you want to find the forward difference of y1, that will be y2 minus y1, y2 minus y1. Then the forward difference of y2 also, that will be a step forward, subtract minus your y2. If your function is in the form of y subscript 0, But if your function is a function of f of x, then the forward difference operator applied to your f of x will be a step forward, which is denoted as your h. That will be f of x plus h minus f of x. Then if you want to find a step forward for forward difference operator, that is the forward difference operator of f of x plus h, that will be f of x plus 2h minus f of x plus h. So if we are going to move a little bit step forward by checking the forward difference operator of x plus 2h, then now we are going to have f of x plus 3h minus f of x plus 2h. Don't worry, by the time we check more example on this, you will have better understanding on it. So that is about the first order. So all this is first order. So this is first order of forward difference operators, and this also is also first order. Okay, so if you want to check the second order, where we have power of 2, so that means that the second order of forward difference operator on y note is that we are going to split the d square. That means that we are going to have d times d, then we put this into bracket. So first of all, find the forward difference of y subscript 0. So by the time we find the forward difference of y subscript 0, we are going to have y1 as this. So we are going to have y1 minus y0. Don't forget the remaining forward difference operator here. So you add it to this, then you open the bracket. By the time we open the bracket, we are going to have forward difference operator for y1 minus forward difference operators on y0. So by the time we find the forward difference of y1, that will be y2 minus y1. Then we do the subtraction sign minus. Then by the time you find the forward difference for y0, that will be y1 minus y0. So by the time you open the bracket, you have your y2 minus y1. Then you have your minus y1 minus times minus, that gives you plus y is 0. So this, you can add this together, minus y1 minus y1 gives you minus 2y. So that means that the second order of forward difference operators for y subscript 0 is equals to y2, y subscript 2 minus 2 y subscript 1 plus y subscript is 0. So what happens if our function is given in form of f subscript 0? We are going to apply the same method. This our delta square now, which is forward difference operators. We are going to split it into 2. That will be, because the square is going to give you dan and then dan. So first of all, check the dan of f of x, and this gives you f of x plus h minus f of x. So then we use this to open the bracket. We are going to have this times this, and then minus this times this. So by the time we find the forward difference of this also, we take a step forward. That will give us function of x plus 2 h minus f of x plus h, then minus minus. If you find the forward difference of this, your f of x also, that gives you f of x plus h minus f of x. So by the time you use this minus to open the bracket, you are going to have f of x plus 2h minus f of x plus h minus f of x plus h plus f of x. So then we have your f of x plus 2h minus this and this, that gives us minus f of x plus h plus f of x. So I believe that is clear enough for us, for you to understand. So let's check example 1 on this. So we have dash square into bracket 3 exponential x. So in final solution of this, so we split this our die into 2 because of the square. We have die times die 3 exponential x. So we bring out the constant out 3, then we have forward difference of exponential x. So by the time we find the forward difference of exponential x, we have exponential, we have your h to your x, that is step 4, we have exponential x plus h minus exponential x. So then we use this our forward difference operator then to multiply everything in this bracket while we take this our 3 outside. So then we are going to have then this exponential x plus h minus then exponential x. So by the time we implement this forward difference operator on this, we are going to have exponential x plus 2h and minus exponential x plus h. Then this your minus sign, we have it here. Then you have your exponential x plus h minus exponential h. So by the time we use this minus to multiply everything in this bracket, we are going to have exponential s plus 2h minus exponential s plus h minus exponential s plus h. So finally we are going to have 3 into bracket exponential s plus 2h minus 2 exponential s plus h plus exponential s, and this gives us our final answer. So that is example 1 on forward difference operator. So let's check this example 2. Show that squared sin x equals to sin into bracket x plus 2h plus sin x minus 2 sin x plus 2h. Alright, so we pick our right hand side in order to get, so we pick our left hand side in order to get the value of our right hand side. Okay, so following the same method, the same step we used in the example 1, so we split this our second order into 2. We have a forward difference times the forward difference sin x. So by the time you find the forward difference of sin x, you have a step forward, that is sin x plus h minus sin x. Then you use this to open the bracket, so this times this, and then your forward difference times minus sin x. So by the time you also apply your forward difference on sin h, that will be a little bit forward, that will be h plus h, and that give you 2h. So that will be sin the bracket x plus 2h minus sin x plus h. The minus sign, then you also find the forward difference for your sin h. So you have sin x plus h minus sin x. So by the time you open the bracket, you have sin x plus 2h minus sin x plus h minus, use this to multiply this, you have this, and minus times minus, you have your plus, then you have sin x. So sin x plus 2h, so this you can see that this and this have the same terms, so we can actually add them together. So minus sin x plus h minus sin x plus h, that gives us minus 2 sin s plus h, close the bracket, and then your plus sin x, and that equals to our right hand side. Alright, thank you so much for watching. Then next time we meet in lesson 2, we are going to check more example on our forward finite difference. Thank you, and don't forget to subscribe to this channel.